Hello everyone, I am on part 3 of the guided notes for homework and notes number 7. I'm looking at example 6, which is on the 3rd page, and I am asking you to find all of these complex zeros that of this function. I'm going to clean this up a little bit. Find all of the complex zeros and then write a polynomial as a product of linear factors. So what I'm looking at here is a function that's going to have 4 roots because its degree is 4. Since its degree is even, I know that its end behavior is going to be the same, and because the leading coefficient is positive, I know it's going to open up. Because of the complex aspect here, that means I could have rational, or in other words real, and they could be rational or irrational, or imaginary roots. So let's work our way through this and we'll see what we come up with. What I'd like you to notice is that the possible rational zeros for this function are the factors of -2 over the factors of 2, the factors of the constant over the factors of a leading coefficient. So my possible rational zeros are plus and minus 1, plus and minus 2. There is a little bit of guesswork here, and I'm going to look at -2 and see if that's a root. So because of our work with the rational zero, with the remainder theorem, I know that f of x equals 0 means that there is a root where, let's say if I plug in a, where x equals a, right? So if I plug in -2 to this function, and I've got 2 times -2 to the 4th plus 3 times -2 cubed plus 3 times -2 minus 2. If I crunch all these numbers, I've got 2 times 16 plus 3 times -8, just put parentheses around that, plus -6, so minus 6, minus 2. So I'm looking at 32 minus 24 minus 6 minus 2. I'm looking at 32, I'm looking at 8 minus 8, I'm looking at 0. Because f of 2, -2, equals 0, I know that -2 is a root, so I know that when I do synthetic division, I'll be able to knock down that polynomial one step. So I'm plugging in 2, I'm plugging in 3. There is no x squared term, so I need to plug in a 0. I'm plugging in 3 and then -2. Not sure. There we go. Now let's do our synthetic division here. Bring down the 2, multiply, -4, -1, positive 2, -4, -1, positive 2, 0. The next polynomial I end up with here is 2x cubed minus x squared plus 2x minus 1. All right. The next process here is to figure out where my roots might be. So x cubed minus x squared is 2x minus 1. Let's see if we can factor by grouping here. I'm looking at this as a 4-term polynomial, and I'm going to see what happens if I take out an x squared, and then on the inside I get 2x minus 1. Here, what if I took out a 1, and on the inside I get 2x minus 1? Some of this recognition, the ability to recognize what to do, just comes with practice. But I know if I've got a 4-term polynomial, I should look to see if I've got some kind of symmetry or matching or pattern so that factor by grouping might work. So it looks like I've got x squared plus 1 and 2x minus 1 as a factor, and of course don't forget that x plus 2 is a factor because x equals -2 was a 0. So what I'm looking at here is the expression for this polynomial as a product of linear factors. I'm looking at f of x is going to be equal to x squared plus 1 times 2x minus 1 times x plus 2. Sure enough, if you were to multiply all of that out, you would end up with the original polynomial. Now, if I'm going to find all of the zeros here, I'm going to set each of these equal to 0. Well, the last one is easy, x equals -2. We know that that's a root. This next one is 2x equals 1, so x equals 1/2 is a root. And then finally, x squared equals -1. Ah, here we go. When I take the square root of both sides there, I get that x is equal to plus or minus I, that imaginary unit. So that means that I have two imaginary roots where x equals plus or minus I, and then two real roots where x equals 1/2 and x equals -2. Okay, this is one of these 5-minute problems that takes up half of the page, but also makes you feel really powerful and empowered when you can do all of this and how much knowledge that you have. So good luck on the homework. I will see you in the next video.